Usually when we talk about a medical diagnosis, there's this expectation of clinical precision.
Oh, absolutely. It's binary.
Right. Like you break your arm, the x-ray shows that jagged white line in your radius, and the doctor just points at the film and says, like, there it is, that's the problem.
Yeah, the fracture exists in physical space. There's no room for interpretation about whether the bone is broken or, what shape it is.
But then you step into the world of building a digital product. Let's say you're leading a new feature launch.
Oh boy.
Suddenly, that x-ray machine it's completely shattered. We're operating in a communication landscape that is, well, entirely abstract.
It really is, because unlike a physical broken bone, a digital product in its early stages doesn't exist anywhere except in the designer's imagination.
Exactly. You have this brilliant, pristine vision of a user interface in your head. You know exactly how the onboarding flow feels, how the modals bounce, where the primary calls to action sit.
Right. It's perfect in your mind.
But trying to transfer that exact vision into the minds of your front-end developers, your product managers, your stakeholders, it is the definition of diagnostic muddy waters.
It's a nightmare. And the tools we historically use to bridge that gap.
Yeah.
Static Jira tickets, 90-page Confluence documents, endless Slack threads.
Don't even get me started on the Slack threads.
Right. They leave a terrifying amount of room for interpretation.
Which is why we're doing something a little different today. We are pulling a specific blueprint to solve this exact communication breakdown.
I'm very excited for this one.
Me too. Our mission for this deep dive is to tear down the core concepts of how you get ideas out of your head and into reality, especially for someone just starting their career. And we're anchoring this entire breakdown on chapter 29, which is called Prototyping, from the book Design User Interface.
It's arguably the most critical chapter in that text, honestly, because it tackles the primary bottleneck in the product lifecycle, the translation phase.
Okay, let's unpack this. Because chapter 29 brings up a concept that everyone listening who has ever survived a, 3 p.m. Tuesday sprint planning meeting will immediately recognize.
The dreaded game of telephone.
Yes, the game of telephone. We've all been there. You write a user story and you describe the interactions in agonizing detail. You write, the settings menu slides in smoothly from the periphery.
Which is a massive trap. What does smoothly even mean in a technical environment?
Exactly. It's so subjective.
Right. To a designer who spends their nights tweaking custom cubic Bezier easing curves, smoothly means a 300 millisecond transition with a slight bounce at the end.
But to a front-end developer.
To a front-end developer who is trying to close 4 tickets before Friday and is already dealing with a bloated React repository, smoothly just means slapping a default linear CSS transition on a div and calling it a day.
Yeah, the message just degrades at every single handoff. It goes from the product manager's market research, to the designer's Figma file, to the developer's VS Code.
To the QA tester's staging environment.
Right. It's not just a cliche game of telephone, it's an actual compounding error rate. By the time it's built, the final product is functionally similar, but viscerally entirely different from what you designed.
And this is where the text introduces the antidote, prototyping.
The ultimate translation tool.
Exactly. What's fascinating here is how the book cites that incredibly famous mantra from the design firm IDEO. A good prototype is worth 1,000 meetings.
That quote alone should be framed in every single tech office.
It really should. Think about the sheer agony of a cross-functional alignment meeting.
Oh, I'm thinking about it. You have, 8 highly paid people sitting in a room for an hour, burning thousands of dollars of company time?
Arguing over whether a multi-step checkout process feels too heavy.
Yeah, the product manager says it's too long, the designer says it reduces cognitive load.
And the developer says the API calls will stall. You just can't resolve that debate with words.
You absolutely cannot. If you try to debate abstract concepts, the person with the loudest voice or the highest title usually wins, right? Regardless of the actual user experience.
100%.
Yeah.
If you walk into that same meeting, drop a phone on the table, and say, here is a simulation of the checkout flow, try to buy this item. Well, the dynamic instantly changes.
You completely bypass the abstract explanation. It just obliterates telling.
It forces everyone to react to the reality of the interface, not their hypothetical idea of it.
So if we accept that prototyping is the only way to stop the bleeding in our communication, we have to look at how we actually build these things today, because the landscape has radically shifted.
It has. So let's look at the foundational definition the source gives us for prototyping basics.
Lay it on us.
The text defines an interactive prototype at its core as a simulation of how the finished product will work. It is a model, a facade.
A digital movie set.
Exactly. And the industry currently splits these models into two distinct categories. First, you have codeless prototypes, utilizing platforms like InVision, Sketch, or Figma's native tools.
And the second?
The second is fully coded prototypes, which lean on tools like UXPin, Framer, or just raw HTML, CSS, and JavaScript.
Okay, we are going to tear both of those categories down to the studs today. But before we get to the tools, Chapter 29 forces us to confront a massive philosophical debate in the design community.
The fidelity shift.
Yeah, the death of the lo-fi prototype.
This is a highly contested space, especially for those who, learned UX design a decade ago.
Like me. The traditional dogma was so strict back then, you always start with low-fidelity wireframes, gray boxes, placeholder text, no brand colors, no typography.
You test the pure structure first, and only after validation do you invest the time into high-fidelity visual design.
Right. But I'm going to push back on the book's premise here, just on behalf of every designer who is operating on a microscopic deadline.
Let's hear it.
If the entire goal of agile prototyping is velocity, like testing things quickly before engineering burns a sprint on it, why would we kill the wireframe? Drawing a gray rectangle takes 3 seconds.
It does.
Building a fully colored, drop-shadowed, typographically perfect interface takes hours, if not days. Aren't we just dressing up a mannequin before we even know if the clothes fit?
That is the most common defense of wireframing. And historically, it was completely valid.
Thank you.
And here is where the source material draws a hard line loathing. Lo-fi prototypes are now extremely rare in professional modern settings.
Really? Extremely rare.
Yes. The math on the time-saving argument has completely changed due to the explosion of design systems.
Wait, so you're arguing that because we have component libraries, we are basically just snapping high-fidelity Legos together? Doesn't that just make everything look like a generic template?
Well, not if the design system is built correctly for your specific brand. Think about what a mature design system in Figma actually does under the hood. A designer isn't drawing a button from scratch anymore. They hit Shift-I, search for primary button, and drag a component onto the canvas that already has the exact brand hex codes.
Right, and the correct corner radius, the proper padding.
Exactly. And the interactive hover states are baked right into it.
Okay, I see the mechanical advantage there. Dragging that pre-styled high-fidelity button onto the artboard takes the exact same amount of time as hitting R and drawing a gray wireframe box.
Precisely. The efficiency argument for lo-fi just evaporates.
It really does, but is that the only reason? Because if it's just about speed, some people might still prefer the gray boxes to avoid stakeholders getting distracted by colors.
That's a fair point, but the text gives a second, far more critical reason for the death of lo-fi. And this dives deep into behavioral psychology.
Oh, I love this stuff.
Low-fidelity prototypes are actually terrible for user testing.
Wait, really? Because they look fake.
Yes, because they scream, "I am not a real product," to the user's subconscious. Think about the cognitive load you place on a user when you sit them in front of a wireframe.
They're trying to figure out what they're even looking at.
Exactly. You're asking them to navigate a checkout flow, but all they see are skeletal gray boxes and, boxes with X's through them, indicating an image.
Right. Their brain cannot enter a state of natural flow.
No, they remain locked in an analytical, evaluative mindset.
They start critiquing the architecture instead of just experiencing the product. You'll hear them say things like, well, I suppose this gray box represents the shopping cart, so I would probably click here.
Yes, they are entirely detached. They are playing along with your game, but they aren't generating genuine behavioral data.
And that detachment ruins your research. Because if I give you a high-fidelity prototype one with your actual brand colors, stunning typography, realistic product photography, a psychological switch flips.
The illusion takes hold. The user stops looking at it as a puzzle to solve and starts interacting with it as a tool to achieve a goal.
The friction becomes real. If the button is in a weird spot, they don't say, I think this placement is suboptimal.
No, they just try to click it, fail, and get visibly annoyed.
And that annoyance, that genuine human friction, is the only data actually worth collecting. If you test with wireframes, you are gathering data on how people react to wireframes, not how they will react to your application.
Which is why the source is so adamant. Sticking to high-fidelity prototypes is the mandatory best practice for gathering accurate user behavior.
Okay, but if we accept that high fidelity is the only way to get real data, the immediate roadblock is execution. We need the illusion of a finished app, But we still can't afford to wait for a developer to write thousands of lines of React just to test a hypothesis.
Right, that defeats the purpose of agile prototyping.
So how do we build that complex illusion rapidly? This brings us to the mechanics of codeless prototypes, which are, frankly, the absolute workhorses of the modern design studio.
They really are. Codeless platforms like InVision or the native prototyping tabs in Figma and Sketch are brilliant because they allow designers to build that high-fidelity movie set facade in an afternoon.
Yeah, you can generate a link, drop it in a Slack channel, and stakeholders can tap through it on their actual phones.
It feels incredibly real to them.
But we need to demystify this because to a junior designer or a non-technical stakeholder, a codeless prototype feels like technological magic.
It totally does.
You click a beautifully rendered button on your screen and the application instantly glides to the next page. But if we pull back the curtain on how these tools actually function, it's shockingly primitive.
Oh, it really is. The text points out that these massive platforms mostly rely on a web technique from the 1990s called the image map.
That is wild to me. It is the ultimate digital sleight of hand. When you are interacting with a codeless prototype, you aren't engaging with code or DOM elements or real text.
No, an image map is essentially an invisible, transparent polygon layered directly over a completely flat, static image file.
It's literally just a JPEG or a PNG of your interface. That drop-down menu you design, it's just painted on.
It's just pixels.
That text input field, just pixels. There is no real button.
Yeah.
The prototyping tool simply lets the designer drag a blue, transparent, invisible square over the part of the flat picture that looks like a button.
Exactly. And when the user clicks that invisible square, the software simply swaps out the current flat picture for another flat picture.
It creates a compelling illusion of navigation. But the text is very clear that designers must understand the severe limitations of this illusion.
They have to, because it operates strictly on static representations connected by invisible hit areas. The only interaction available is the click or the tap.
Right. You can't actually type your email into that beautiful input field. You can't drag a slider to change a price filter. You can't highlight text.
You are locked into a highly scripted path. It's essentially an interactive slideshow.
And even within that scripted path, there is a deep strategic debate happening in the industry about how we draw those invisible image maps. The source outlines two distinct methods for creating these hit areas, and the implications for user research are profound.
It's a fascinating debate. Let's get into that because this blew my mind. It seems like the most granular, boring detail imaginable, how big you draw the invisible box, but it changes everything.
It really does. Break down the two choices for us.
The text explains the two choices. First, you can link the object directly. This means you make the clickable area the exact pixel-perfect size of the visual button you designed.
So if your button is 120 pixels wide and 40 pixels tall, your invisible hit area is exactly 120 by 40.
Exactly. The second option is to draw the image map manually and make it drastically larger than the visual button, turning the entire surrounding white space into a clickable trigger.
Okay. My immediate instinct, and I think the instinct of any designer who obsesses over their craft, is to use the first option. I want it to be exact.
Of course, you want precision.
Yeah. If I draw a massive invisible cheat box around my tiny button, I feel like I'm rigging the user test. I want the most realistic representation of my interface.
That's a valid instinct for later stages, but the source actually advocates heavily for the second option, drawing much larger image maps during initial testing.
Wait, really? Why?
Let's analyze the mechanism of a user test. What are you actually trying to validate in a first-round prototype?
I guess you're trying to figure out if the architecture makes sense. Do they understand that to edit their profile, they have to click the gear icon?
Exactly. You're testing the flow, the cognitive journey. You are not testing their fine motor skills.
Okay. I see where you're going with this.
Right. If your hitbox is pixel perfect and a user is testing on a phone with their thumb, they might attempt to tap the gear icon, but miss the active area by 2 pixels. The prototype does nothing.
Oh, wow. And the user immediately thinks, oh, the gear icon doesn't work. Or worse, the gear icon isn't the right answer.
Yes. They abandoned the correct path, not because they didn't understand the interface, but because they had a slightly clumsy thumb.
You've just generated a false negative in your research.
A completely avoidable false negative. You might go back to your desk and redesign the entire navigation system based on the false assumption that users couldn't find the settings menu.
That is terrifying. So by artificially expanding the hit areas early on, you eliminate technical friction. You validate that their intent was correct.
Exactly. You ensure the map is accurate before you worry about the vehicle. But the text doesn't completely dismiss exact sizing, does it?
No, it embraces it for a later phase. The text notes that linking exactly to the visual object size is the closest approximation of reality. Once you've validated the overall flow using the large cheat boxes, you switch to exact sizes to test usability.
Right, because then you're testing ergonomics.
Exactly. If users are consistently failing to trigger a button because the exact hit area is too small, that data is gold. It forces you to update your touch target sizes in the design system. The interface is objectively too difficult to manipulate.
It's a brilliant two-stage process. Test the logic with big hitboxes, test the ergonomics with exact hitboxes.
And building these connections is getting so much easier now. We aren't exporting JPEGs and manually drawing boxes in a separate web browser as much anymore.
Thank goodness. The text highlights plugins, like Craft for Sketch, which sync directly to platforms like InVision, allowing you to build the connections right inside the design canvas.
It makes the process so frictionless that the book literally states it'd be a shame not to do it.
Because doing it yields a secondary artifact that is incredibly valuable for the broader product team.
Oh, flow diagrams.
Yes. Once you connect all these screens, the software generates a flow diagram.
I love flow diagrams. If you look at the prototype view in Figma, it looks like a chaotic neon spiderweb.
It really does look like a mess.
Every single artboard is laid out on a giant infinite canvas with hundreds of intersecting arrows showing exactly which button leads to which screen and which modal loops back to which dashboard.
It looks chaotic to an outsider, but to a developer, a flow diagram is a map out of the wilderness.
Think about the alternative.
Exactly. If you just hand a front-end developer a clickable prototype and say, build this, they have to play detective.
They have to click through every single variation, every edge case, trying to memorize the invisible logic tree you've built.
And they'd inevitably miss something. They'd come back and say, wait, I didn't know clicking the user avatar on the checkout screen over to a completely different side panel than clicking it on the home screen.
And that causes huge friction. But the flow diagram gives them a true bird's eye view of the application's architecture.
They can visually trace all 3 exit routes from the checkout flow. They can see the logic loops perfectly.
The source material is explicit here. It is a mandatory good practice to add this flow diagram to your project documentation alongside the interactive link. You have to provide both the experience and the map of the experience.
But, a map only shows you where things are. It doesn't dictate how you travel between them.
Right. And this opens up a conversation about an element of UI design that is so subtle, most users don't even realize it's happening, yet it completely dictates their understanding of your app.
We're talking about transition types.
Yes. The subconscious power of transition types. I find this fascinating because it touches so deeply on human psychology. We established we are building this high-fidelity illusion. But what happens if the user taps a button and the screen just violently, instantaneously replaces the current screen with no animation?
The illusion shatters.
Just completely breaks.
The text makes a crucial distinction here. When you are just sketching out a flow internally with your design team, when you're just trying to agree on the number of steps in a process, the default instant transition is fine. It's fast.
Sure, internally you just need to know A goes to B.
But here's where it gets really interesting. The moment you put that prototype in front of a real user or a stakeholder who isn't steeped in UX theory, an instant transition feels like an error.
It feels jarring, like a web page from 1998 that just performed a hard refresh.
Exactly. And that brings us to the foundational rule of transitions that the text lays out. Transitions must show where each screen exists in space.
We basically have to invent digital physics. We are working on a flat, two-dimensional piece of glass, but we have to trick the human brain into believing there is a three-dimensional spatial architecture happening behind that glass.
Because human beings evolved to navigate the physical world spatially, we understand our environment based on where objects are located relative to one another.
Right. If you walk into a room, you know the hallway you just left is behind you.
Yes. Our brains subconsciously demand those same spatial rules when looking at a digital interface.
So how does the book break this down in practice? Because it's one thing to say digital physics, but how do we build it?
It gives a very clear spatial model. If you are moving forward in a journey, say going to the next step in a checkout flow or diving deeper into a settings menu, the new screen should slide in from the right side, pushing the old screen away to the left.
Okay, so it physically visualizes forward momentum, like turning the page of a book. The new information comes from the right, pushes the old information into the past on the left.
Correct. But the true psychological test of your interface's spatial logic is the back button.
Oh, this part was eye-opening.
The source details the immense psychological weight of this specific interaction. Think about the universal placement of the back arrow. In iOS, in Android, in almost every web browser, the back button sits in the top left corner.
Because it's pointing backward.
Because it's pointing backward, yes. The user's mental model is firmly established. The previous screen is currently being stored somewhere off-screen to the left. Therefore, when the user taps that back button, the previous screen must slide in from the left side.
It has to slide in from the left to validate the user's subconscious assumption. It proves to them that the screen was sitting right there, waiting behind the bezel of their phone the entire time.
Now, imagine the cognitive jolt if you get that wrong. Imagine the user taps the back arrow on the left, but you've animated the old screen sliding in from the right.
I would instantly feel disoriented. My brain would think, wait, that's not where I left that. Did I just go further forward? Did I enter a loop?
The text warns explicitly about this. Doing transitions wrong causes a massive amount of confusion because it defies the user's relational expectations. You break their trust in the environment.
If your digital physics are broken, the user feels lost, even if your visual layout is stunning. They rely on that half-second animation to understand the architecture of your app.
It's incredible how much heavy lifting a simple slide animation does for our cognitive mapping.
It really is. But, even if you perfectly map out your image maps and your spatial transitions are flawless, codeless prototypes still hit a brick wall.
They do. They're still just pictures.
Exactly. You can't test a complex data entry form with pictures. And that reality introduces the next major evolution the book covers, the coded prototype revolution.
Codeless is brilliant for rapid iteration and securing stakeholder buy-in on the general flow. But you inevitably hit a phase where you need unprecedented, true-to-life interactivity to validate complex mechanics.
You need the user to type in a messy, real-world email address and see how the UI handles inline error validation. You just can't fake that with an image map.
No, you can't. We have to shift to fully coded prototypes.
The text lists the heavy hitters here, right? UX pin, framer, or literally just spinning up a local environment and writing raw HTML, CSS, and JavaScript. And the leap in capability is just staggering.
The source emphasizes that in this environment, everything must function. Forms must validate. If I leave a required field blank, the prototype must throw a realistic error state.
Microinteractions actually come alive. If I click a favorite button, it shouldn't just instantly turn red, it should execute the subtle scaling animation you designed.
But the real superpower is external data. The text mentions that coded prototypes allow you to pull in live APIs.
Oh, that's huge.
You aren't taking a screenshot of Google Maps and making it a static background anymore. You are embedding a functional Google Map that the user can pinch, zoom, and interact with during the test. You could embed fully functional YouTube players.
So the illusion ceases to be an illusion. It crosses the threshold into becoming a functional piece of software.
Exactly. And if we connect this to the bigger picture, this triggers a paradigm shift that I think is the most disruptive concept in modern product design.
Let's get into it because this fundamentally changes the job description of a designer.
Historically, the workflow was incredibly wasteful. The designer spends weeks building a fake version of the app. The client approves the fake version. The designer then throws the fake version in the digital trash, hands a stack of JPEGs to the engineering team, and the developers build the real version completely from scratch.
It's an insane duplication of effort. You're building the house twice.
But the text notes that with the maturation of design systems, this archaic process is dying.
Thank goodness.
If your team is operating correctly, a coded prototype is not built from scratch. It is assembled using the exact same library of React components that the engineering team will use for production.
The butters, the input fields, the navigation bars, they're pulling from the same single source of truth.
Yes, so the prototype isn't a throwaway model anymore. The prototype is the code.
Wow.
The text asserts that in many cases, after the testing phase is complete and a few final tweaks are made, these coded prototypes actually transition into becoming the front-end components of the finalized app.
The line between prototyping and front-end development is just evaporating.
And the source suggests this is rapidly becoming the leading approach for the entire industry.
Which is wildly efficient. But I'll play devil's advocate here. If you are a designer who has spent your entire career mastering typography, color theory, and user psychology inside of visual tools like Figma,
It's intimidating.
it's terrifying.
Yeah.
Hearing that your prototype needs to become production React code. The book addresses this reality head-on, right? The blending of competencies.
It's a harsh but necessary career advisory. The text points out that literally anyone can learn to string together a codeless prototype in an afternoon. It requires zero technical skill. But shifting to a coded prototype framework demands a competence shift.
So what is the new baseline? Does every designer need to become a full-stack engineer?
No, and the text doesn't suggest that. It advocates for a pragmatic baseline. Designers must learn at least CSS.
Okay, just CSS.
You have to understand how the web physically renders layouts. You need to understand the box model, how Flexbox behaves when it runs out of space, how viewport typography scales.
I think that's incredibly fair. You can't be a master architect if you don't understand the physical properties of steel and concrete. If you don't know how CSS behaves, you will design interfaces that are fundamentally impossible to build efficiently.
Precisely. The text notes that often just having a designer who understands CSS is enough to bridge the gap with the developer.
Right.
But it goes a step further, suggesting that learning a bit of React or plain JavaScript can dramatically elevate the quality of a designer's work, allowing them to build these high-fidelity interactions themselves.
But the burden isn't entirely on the designer. I love how the source approaches this as a two-way street. Front-end developers aren't off the hook.
Not at all. The text explicitly states that front-end development is now so intrinsically linked to the user experience that developers must also evolve.
Designers must understand the front-end code, and front-end developers must understand design principles.
Yes. They need to understand why an 8-pixel grid matters, why typographic hierarchy guides the user's eye, and why that custom easing curve isn't just a vanity metric, it's functional feedback.
The source actually defines what the optimal team looks like in this new era. It calls it the best teams concept.
The best teams consist of design-driven developers and designers who know a bit how to code.
We aren't asking for mythical unicorns who are world-class at both disciplines. We are asking for T-shaped professionals, people with deep expertise in their primary field, but enough horizontal knowledge to speak the other discipline's language fluently.
When you achieve that overlap, the friction disappears. The designer doesn't hand off a physics-defying animation that crashes the browser.
And the developer doesn't push back with a clunky default UI because they understand the value of the design nuance.
They collaborate. And the text offers a beautiful summation of this dynamic. You should treat your coded prototype like a door to the final product front end.
Treat your coded prototype like a door to the final product front end. It's a brilliant mindset shift. But, and this is a massive trap that destroys even the most perfectly coded prototypes built by the most blended, T-shaped teams in the world.
Let me guess. Garbage data.
Yes. If you take that pristine React prototype and you fill it with garbage data, the entire illusion evaporates.
This brings us to one of the most dogmatic, hardline stances in Chapter 29, the real data mandate.
The book effectively declares all-out war on lorem ipsum.
And rightfully so.
Yeah.
It is a massive pet peeve in the industry. The text is unambiguous. When creating prototypes, avoid lorem ipsum and dummy images.
If you are designing a dashboard that displays a list of recent customers, you absolutely cannot just write first name, last name down the page 12 times.
It looks clean, it looks symmetrical, but it's a lie.
The source commands designers to use real-looking data. Now, to be clear, they do not mean violating GDPR privacy laws by pulling actual live customer data into an insecure prototype.
Right, definitely don't do that.
What they mean is that you must painstakingly simulate reality. The text introduces the concept of creating virtual humans.
You essentially have to become a digital novelist for a minute. You have to invent people, give them a name, give them a realistic job title, source a believable profile photo.
The text gives a great benchmark. Instead of writing user 1, you write Anna Smith, HR manager.
And the text gives a vital warning about human pattern recognition. Do not duplicate these virtual humans. Don't build one perfect Anna Smith and copy-paste her 10 times to fill out your list.
Oh, because the human brain is an apex predator when it comes to spotting patterns.
It is.
If I'm a user testing your app and I see the exact same smiling stock photo of a woman repeated 5 times in a column, my brain instantly registers fake environment.
The immersion is broken. You're back in analytical mode, evaluating the layout instead of experiencing the product.
The prototype must reflect the chaos of reality as closely as possible.
And I want to take the concept of chaotic reality a step further, because the tactical reason for doing this is brilliant.
Let's hear it.
Using messy, real-world data in a prototype is exactly like stress testing a newly built suspension bridge.
Okay, I like this analogy.
You don't just drive one perfectly balanced, lightweight electric car over the bridge on a sunny day and say, yep, the math holds up, open it to the public.
No, of course not.
If you want to know if the bridge survives, you run a convoy of overloaded freight trucks across it during a hurricane. You have to push the structure to its absolute breaking point.
That is the exact mechanism the text advises. It tells designers to intentionally hunt down the longest names, the most complex data strings, and the largest numbers to inject into their prototypes.
Why? To see exactly how and where the UI fails. Let's play that out. If you design a gorgeous, minimalist user card and it looks flawless when the data reads John Doe, CEO.
What happens to your CSS flex box when the user's name is Hubert Blaine Wolf Schlegel Steinhausen Bergerdorf?
Exactly. How does the architecture fail? Does the text gracefully truncate with an ellipsis? Does it wrap to a second line and push the entire layout down, breaking the grid?
Does the text literally bleed outside the borders of the card and overlap the user's profile picture?
Do the spatial transitions we perfected earlier suddenly drop frames and stutter because the DOM is struggling to render the massive data payload?
By using extreme, real-looking data, you are proactively stress testing the interface. The text asks the fundamental questions. Is it still readable? Or is an adjustment needed?
You desperately want to find out that your layout shatters under the weight of a 50-character name now, while it's just a prototype in a Figma file or a local branch.
Right, not 3 months from now when it's live production code and thousands of German users can't read their own profiles.
Which logically leads us to the ultimate purpose of this entire methodology. Why do we go through this agonizing process?
Why do we avoid the game of telephone, force ourselves to learn CSS, debate spatial transitions, and painstakingly invent chaotic virtual humans just to break our own designs?
It all culminates in the final section of the text: research and the ultimate return on investment.
Prototyping is not an artistic exercise. It is a ruthless data-gathering mechanism.
The text summarizes that the ROI of prototyping rests on two main pillars. The first, which we touched on earlier, is securing buy-in.
It is the fastest way to make non-technical stakeholders, CEOs, and investors genuinely understand the product vision.
But the second pillar is the actual engine of product development, creating a functional model on which you can conduct rigorous empirical research.
The text states unequivocally that the gold standard is testing on real target demographic users.
However, it also makes a pragmatic point. Even internal office testing, grabbing a coworker from the legal or accounting department who has never seen the design, can expose massive blind spots you couldn't predict while isolated in your design silo.
And the book doesn't just say, go test it. It lists specific modern methodologies for gathering this data.
It advocates for in-person interviews where you can watch the micro-expressions of frustration on a user's face.
It mandates screen recording so you can track exactly where the mouse cursor hesitates before a click, because that hesitation is the physical manifestation of cognitive load.
And it suggests heat map generation to visually contrast where the user's attention actually went versus where your visual hierarchy tried to force it to go.
The sole objective of all these methodologies is to identify what the text calls flow problems. And the ultimate metric for measuring a flow problem isn't aesthetic, it's time.
How long does it take a user to accomplish the primary task? Time is the ultimate truth teller.
If you've designed a visually stunning, award-winning interface, but it takes a user 3 full minutes of hunting and pecking to figure out how to update their billing information, your design is a failure.
The prototype gives you a safe, isolated environment to measure that failure.
This raises an important question, though. How agile is your process?
The text emphasizes that the entire philosophy of prototyping hinges on velocity. It describes a continuous, relentless cycle. Build the prototype, execute the research methodologies, gather the empirical data, rapidly adjust the prototype to fix the identified flow problems, and immediately test again.
It's an evolutionary loop.
Exactly, and this iterative loop is the only proven way to forge a problem-free interface. But the text inserts one final, dire warning about this testing phase.
Reiterate it for the people in the back.
Do not attempt to run this research cycle using wireframes or dummy data.
Garbage in, garbage out. If you test with a skeletal gray box filled with lorem ipsum, users will not treat it like a real product, and the data you gather will be entirely theoretical and utterly useless.
And gathering accurate data is what protects the company's bottom line. The text drives home the ultimate financial reality of software development. It is exponentially cheaper to iron out all possible flow problems in a prototype than it is during active development.
Imagine the cost disparity. If a user test proves that the fundamental navigation architecture of your app is flawed while you are in the prototype phase, the designer spends 4 hours rearranging components and you retest tomorrow.
But if you discover that same fundamental flaw after the product is fully developed, you are looking at pulling back months of work.
You are rewriting thousands of lines of back-end database routing, refactoring the front-end components, and burning hundreds of thousands of dollars in engineering salaries.
Prototyping isn't just design. It's the ultimate financial insurance policy for a tech company. It's risk mitigation in its purest form.
Let's pull all of this together because we have covered a staggering amount of technical ground today. We started by confronting the reality of the game of telephone, the fact that written documentation degrades, and we must show rather than tell to achieve true alignment.
We examined the death of the lo-fi wireframe, understanding that the componentization of design systems means high fidelity is now just as fast to build, and crucial for moving users out of an analytical mindset and into genuine behavioral interaction.
We deconstructed the mechanics of codeless tools, revealing the magic of the invisible image map, and debated the strategic advantage of drawing massive hitboxes early on to test logic, before narrowing them down to test ergonomics.
We learned why handing a flow diagram to a developer is the ultimate act of professional empathy.
We dove into the deep subconscious psychology of spatial transitions, the digital physics that dictate why a back button demands the previous screen slide in from the left to validate the user's mental map of the interface.
We explored the paradigm-shifting revolution of coded prototypes. We looked at how validating complex APIs and real-form inputs in code is blurring the lines between design and engineering,
Forcing the evolution of the T-shaped professional where designers learn CSS and developers master UI principles.
And finally, we declared war on lorem ipsum, understanding that we must invent virtual humans with chaotic, extreme data to stress test our UI components before they hit production.
All in service of generating bulletproof research to save the company from catastrophic development costs. It is a profound end-to-end masterclass in product strategy.
It really is.
And listen, if you are a designer, a product manager, or a developer trying to navigate these murky waters and build products that actually survive contact with reality, you absolutely need to go straight to the source material.
Highly recommend it.
The book we have been breaking down today is called Design User Interface. It is a goldmine of this exact level of practical, industry-tested, zero-fluff wisdom. I'm going to share the exact book link with you right now, verbally. It is https://hype4academy.gumroad.com/lyrabook.
It's an essential read.
I cannot recommend this enough for your career toolkit. In fact, you can buy the book right now by scanning the QR code of the book link provided in the description below.
Make sure to check that out.
And as we continue to tear down the most critical concepts in tech, we explicitly request the audience to follow the show for more technical design breakdowns and career-building content. We are going to keep hunting down these incredible resources to help you level up your workflows.
It has been a genuinely fascinating exploration of how we translate abstract human intent into functional digital reality. The evolution of these tools is moving at breakneck speed.
It really is. And as we wrap up, I want to leave you with one final thought to mull over. We spent a lot of time today talking about how coded prototypes are essentially becoming the actual front-end components. We talked about designers writing React and developers mastering design systems.
Yeah, that blurring of the lines.
So what does this all mean? If this technological trend continues, if our design tools begin to output production-ready code natively, and the illusion becomes functionally indistinguishable from the reality, where does the prototype actually end and the final product begin?
That is the million-dollar question.
Are we rapidly moving toward a future where prototyping isn't a separate, distinct phase of the product lifecycle at all? Is it possible that in the next few years, the word prototype simply disappears from our vocabulary and becomes just another way of saying the first draft of the final code?
It's a very real possibility.
It is a wildly blurry line, and it's only getting blurrier. Something to think about the next time you sit down to start a new project. Until next time, keep exploring the deep end.